This is the first update for MoonDAO project MDP 265, the interactive NASA lunar base model. The goal is to turn lunar mission ideas into something people can see, question, change, and test together. Instead of keeping terrain, habitats, rovers, power systems, and mission plans in separate documents, we are connecting them in one interactive environment. A beautiful scene by itself is not enough. A simulation by itself is difficult to understand. The useful result is a visual model with engineering behavior behind it. We did not begin from an empty scene. The work already includes South Polar terrain, habitat studies, power and life support models, lander and rover work, communications experiments, and an open simulator that can bring these pieces together. This first milestone is a foundation review. We are documenting what exists, checking the workflows, comparing local work with the public repository, and deciding what belongs in the first shared scenario. The first major question is location. Near the lunar South Pole, a few kilometers can change the mission. One ridge may receive useful sunlight. Another area may spend long periods in shadow. Slopes affect rover routes. The horizon affects communications with Earth. Permanently shadowed regions may contain useful resources, but they are more difficult to reach and operate in. Current terrain work focuses on the Shackleton and de Gerlache region. The next step is to choose one exact working area, record the terrain source, and keep that choice consistent across the scene, route planning, and systems model. The scene work is moving from a blockout toward a structured environment. Habitat placement, base pads, terrain, and supporting assets are being tested together. These views expose practical questions. Is the habitat on a workable surface? Is there room for a lander? Can a rover route connect the important areas? Does the layout make sense operationally? A lunar habitat is not only a group of 3D objects. It needs power, thermal control, batteries, and life support behavior. Solar production changes with the sun angle. Batteries charge and discharge. Temperatures move over time. A failure in one system can affect the rest of the operation. The HAB1 work in Lunica and Medelica gives us a foundation for showing those changes. It can display a nominal run, but it can also show an unstable or failing condition. A lander can deliver power or cargo. A rover can travel between the landing area, the habitat, and a resource target. A relay or mast can show whether the route remains connected when terrain blocks the horizon. NASA, Artemis, CLPS, rover, lander, power, and lunar resource research is the starting point. We are separating published mission information from engineering assumptions and recording the source of each number before it enters the model.